Now that we've graphed exponential functions, we're going to try to graph some logarithmic functions. And so remember that exponentials and logs are inverses of each other. So exponential and logs are inverses of each other, are inverses. And so remember, when they're inverses, what we have are our x values and y values switch. They switch. So in order to graph logarithms, what we're going to do is, what we're first going to do is graph the inverse. We're going to graph our exponential function. So we have, and then what we do with that then is we're going to switch the roles of x and y, which is why there are two tables here. So first we have 4 to the log base 4 of x, log base 4 of x, and so that inverse is 4 to the x. The inverse is 4 to the x. So let's graph that, 4 to the x. So let's choose some values. I will choose 0, 1, 2, 3, -1, and -2. So if we plug in 0, so 4 to the 0, that is 1. 4 to the first power is 4. 4 squared is 16. 4 to the third is 64. Then 4 to the -1 is 1 over 4. 4 to the -2 is therefore 1 over 16. So those are the basic points of our 4 to the x. And then so what we're going to do is, because they are inverses, and the exponential and the logs are inverses, we can switch the values. So that means that my y values will now be the x values from the 4 to the x. So -2, -1, 0, 1, 2, and 3. And then our y values will be the x's below. So 1/16, 1/4, 1, 4, 16, and 64. So our goal is really just to graph our log. So this is the values for our log. So let's graph that. I like starting at the 1, 0 here. So x is 1, y is 0. So the point is right here, 1, 0. Then let's choose the next one. So at 4, x is 4, we're at 1. So 1, 2, 3, 4, we're at a +1. And then I can't go any further than that. 16 is way off the graph. So let's go backwards. So at a 4th, we're at -1. So x is a 4th, then y is -1 right here. And then it's just going to go closer and closer to these y-axis here. And so the y-axis is actually our asymptote. So from our exponentials, remember the exponentials, the asymptote was the x-axis. So for log, it's now the y. And again, that should make sense because they're inverses, right? So they switch the roles of the x and the y. So here is a graph of g of x log base 4 of x. And you don't have to graph the exponential, we just want to graph the log. And the reason why we can't go beyond this axis here is because logs, remember that logs, we cannot have negative numbers here. Okay, so you can't have like a -2, it's not allowed, so that's a restriction of our graph. So example B, you can try that out, log 2 of x. So just to help you out, the parent function would be 2 to the x. Okay, so try this out. Pause the video and try this out. So if we tried it out, here is our graph. So first you find the values for 2 to the x. So we chose -2, -1, 0, 1, 2, and 3. You should have gotten 1/4, a half, 1, 2, 4, and 8. The next, you just switch the roles of x and y. So the x becomes the y becomes the x. So now our x values are a 1/4, a half, 1, 2, 4, and 8. And the y values are -2, -1, 0, 1, 2, and 3. So I always start in the middle here with the 1, 0. So this is 1, x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. Then I can't go any further than that. Then at a half, x is a half, we're at -1. So you can kind of see where it's headed. And then the asymptote is again on that y-axis. Now let's talk about some transformations of logarithmic functions. And so horizontal translation, that again is right and left, right or left. And it's going to be with the x in the parentheses, with x in parentheses. So we're going to look at log and then x minus h plus k. So that's what we're looking at. So our h and our k there. So with the right, that's going to be a minus h. With the left, it's going to be a plus h. So 3 units to the right, we're just using log of x. Remember, that's log base 10 of x. And so this is going to be log of x, just log, and then parentheses x to the right is minus 3. Then 2 units to the left, it's log of x, and to the left is a positive 2. So inside with the parentheses. For the vertical translation, then it's either up or down, and it's going to be outside. So it'll be here, or plus k. So plus k is up, minus k is down. So for this example, we have log, and then 5 log x, and then 5 units up, that's plus 5. So outside, no parentheses. 1 unit down, that would be log of x, and then minus 1. So no parentheses there as well. So when you're graphing something that's transformed, the best thing to do is to graph the exponential, and then, graph the exponential, find the values of the exponential just like we did here. So find the inverse, and I'm going to do it without the shift. So when we have log base 3 of x plus 2, then we're going to graph our f of x is 3 to the x. Okay, so whatever the base is to the x power. So we're going to focus on finding these values for 3 to the x first. And so 0, 1, 2, 3, -1, -2. And then so 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9, 3 cubed is 27. At -1 we're at a third, and -2 we're at a ninth. So again, these are just for the 3 to the x, and then we're going to switch the roles. So -2, -1, 0, 1, 2, 3, and then 1/9, 1/3, 1, 3, 9, and 27. So what we're going to do is graph first our log base 3 of x. And so we start at that 1, 0. Then at x, we're at positive 3 up 1. Then I can't go beyond that. But let's graph the 1/3 and -1. So at least 3 points. So this is our g of x. Well, it's not their g of x. This is our log base 3 of x. Now what we're going to do last is just apply the transformation. So this means up 2. So you're going to just take this curve and move every single point up 2. So up 2, and then up 2. And now here's our graph. So that's the best way to approach this, is just through transformation. So graphing the log base 3 of x, just like we did in our last examples. And then after that, then applying the transformation. Now with the log base 3 of x, it doesn't transform, if it's going up or down, it doesn't move our asymptote. But for a left and right one, it will. So see if you can try this example, log base 2 of x minus 2. So you're trying to graph, so if it's log base 2 of x minus 2, what is the exponential we're looking at? So the exponential we're looking at is base 2 to the x. So you can either remember the values from before or just fill it out again and then flip them, graph the log base 2 of x without the transformation, and then transform it. So here is the graph in pink here. This is our log base 2 of x minus 2, so right 2. So here are the values you should have gotten for log base 2 of x. And then, so I graphed that here in purple. Then I moved each point 2 to the right. And notice when I move to the right, my asymptote moves along with it. Okay, so hopefully that helps you out. Try number 2, or finish up with number 2 and number 3. And then number 3 is a combination transformation. So then you'll move it this many right or left, and then also up. So just a combination transformation for you to try.